Deep within their roiling clouds, thunderstorms hold an elusive surprise. Under just the right conditions, they produce some of the highest energy radiation naturally found on Earth, terrestrial gamma-ray flashes. Collisions among rain and snow cause different parts of the cloud to develop positive and negative electrical charges. When the strength of the electric field overcomes the insulating properties of air in the thundercloud, a lightning flash occurs. Most lightning occurs entirely within the cloud and is called an intra-cloud flash.
All lightning produces a strong and sudden change in the storm's electric field, but the upward portion of an intracloud flash sometimes sends a surge of electrons rushing toward the upper part of the storm. Reaching speeds nearly as fast as light, these accelerated electrons give off gamma rays when their paths are deflected by air molecules. As energy and updraft strength increases and the storm dynamic moves further from equilibrium, the Newtonian fluid mechanics, Navier-Stokes, are expected to fail and no longer accurately describe the storm dynamics. It is this point where the electromagnetic Lorentz force becomes the predominant governing force. The Lorentz force is an electromagnetic force in which a magnetic field imposes a circular motion on charged particles which begin to emit radio waves. This force was proposed as a contributor to tornado genesis over 30 years ago, but was rejected for a variety of reasons. However, several factors now call for a re-examination of the Lorentz force as a possible contributor toward tornado genesis. These factors include new field evidence, a better understanding of tornadic parent storms, and a close evaluation of the previous objections. The Lorentz force may indeed play a significant role in tornado genesis, and a better understanding of this force may in turn provide meteorologists with better understanding of tornadoes and tornado genesis. The inclusion of the Lorentz force in our modern tornado genesis theories can answer several questions inherent in other theories, such as why we observe tornado vortex signatures aloft as much as 20 minutes before tornado touchdown, what force is responsible for the initiation of the tornadic vacuum, and how can tornadoes exceed the thermodynamic speed limit. Once the convection core, also known as a chimney or vault, has become predominantly influenced by the action of the Lorentz force on charged particles, the plasma pulse generator, an extension to the tornado pulse generator located at about 18,000 feet AGL, begins emitting continuous radio waves which are easily distinguished from lightning discharge atmospheric radiation or SFER-X radio waves. Rising and falling snow and ice particles repeatedly collide, filling the cloud with electrical charge as a result of the Leonard-Spray electrification effect. Different parts of the cloud develop positive and negative electrical charges. When the strength of the electric field overcomes the insulating properties in the thundercloud, a lightning flash occurs. Lightning further dissociates water vapor in the cloud into more charged particles. Electrical charge can exist in the cloud without lightning discharges necessarily taking place. Absence of lightning does not mean absence of charge. Charged particles are lifted upward by powerful winds in the convection core. Although there is a strong link between updraft and lightning frequency, the relationship is not distinct. The initial environmental conditions, the updraft speed and more significantly the Graupool number concentration are known to have a large effect on charge density and lightning flash rates. No definite relationship between lightning frequency and cloud ice content has been established. The Lorentz force is known to contribute to a thunderstorm's electrical characteristics because of the electric and magnetic forces exerted on the electrified hydrometeors in thunderclouds. As the electric field increases in thunderstorm conditions, the increased electric field strengthens the induction mechanism of cloud electrification and influences the electrical properties of thunderstorm, including imparting a circular motion on the charged particles. The Lorentz force, the exerted force on a moving charged particle due to the combined electric and magnetic fields, may be a possible contributor to the formation of tornadoes. The charged areas of the cloud tend to place between 3 km and 10 km above the Earth's surface. Water droplets and ice crystals in the clouds are thought to be the charge carriers which produce huge electric fields, interacting with the Earth's magnetic field. Most lightning occurs entirely within the cloud and is called an intracloud flash. All lightning produces a strong and sudden change in the storm's electric field, but the upward portion of an intracloud flash sometimes sends a surge of electrons rushing toward the upper part of the storm. The plasma pulse generator is so named for the electric charge produced by Leonard's spray electrification water vapor dissociated by mechanical and electrical field means, associated with the entire convection core or chimney. This device is an extension to the tornado pulse generator identified by Tornado Jones. VLF radiofrequency radiation is produced by the positive corona streamers coming from sprayed disintegrated drops in a high electrical field associated with a strong convection core or chimney. Also known as cyclotron radiation, radio frequencies which are created when charged particles are trapped in a magnetic field. The Lorentz force acts perpendicular to both the magnetic field lines, creating an acceleration of charged particles that are moving perpendicular to the field. This acceleration, in turn, creates radiation in the form of radio waves. As an example, what is the expected frequency of radio waves emitted by charged particles trapped in the 1000 Gauss magnetic field of Jupiter? Answer: 2.8 times 1000 MHz equals 2.8 GHz. Harmonics, or frequencies which are an integral multiple of the original frequency, are the result of imperfections in the actual emission environment. The easiest place for radiation to be created by particles that are not near the speed of light is at an integral factor higher. In other words, frequencies at exact multiples can be expected to be produced, for example both 550 kHz and 55 MHz, or a whole number multiple of 100. These emissions from the plasma pulse generator are continuous, whereas lightning-generated spherics are brief, discontinuous and sporadic. Arizona University researchers Kreider and Muser have studied Maxwell electric currents under thunderstorms supported by NASA grants in 2013. Time variations observed in thunderstorm electric fields may be interpreted in terms of a total Maxwell current density, varying slowly with time in the intervals between lightning discharges, which can be used to estimate and map thunderstorms. Using the quasi-static behavior of the Maxwell current density, an expression is derived for the field-dependent current density under a thunderstorm during the field recovery following a lightning discharge. Values of air conductivity under the small storm which range from 2 to 6 times 10 to the -13th mho per meter are inferred. Data are presented which indicate that the area average Maxwell current is not usually affected by lightning, and instead varies slowly throughout the evolution of the storm. In light of this, it is suggested that cloud electrification processes probably do not depend on the cloud electric field as much as on the more slowly varying storm dynamics and meteorological structure.
The Mystery of High-Energy Cosmic Rays. Presented by Science at NASA. Hold out your hand for 10 seconds. A dozen electrons and muons just zipped unfelt through your palm. The ghostly particles are what scientists call secondary cosmic rays, subatomic debris from collisions between molecules high in Earth's atmosphere